Today is November 5th, 2019. Happy National Nacho Day. I'm Mr. Trutna. We're going to go over Unit 6, Worksheet 1, numbers 1 to 7, and as is tradition, here's our joke. I keep imagining I'm holding an invisible deck of cards. No one knows what I'm dealing with. There we go. Okay, remember, after the video, smash that like button. Okay. All right, here we go. So here is worksheet 6. It's pink. You probably can't tell that on the worksheet, but we're going to go over the very front side of this, numbers 1 through 7. Okay, so let me zoom it in. Oops, zoom it in. Come on, zoom it in. All right, just a little bit. So numbers 1 and numbers 2, the instructions are right here. And the instructions say list the pairs of congruent angles and the extended proportion that relates the corresponding sides for the similar polygons. So we have this polygon here, ABCD. We have this other polygon here, WXYZ, and it tells us that they are similar polygons. So the first thing we're going to do is we're going to make a list of the angles that are congruent to each other. So angle A is congruent to angle W. And when you do this problem, don't just put a W, put the angle symbol in front of it, okay? And here's why. So for instance, angle B is the same as angle X. If you just put an X right there, remember, that would signify to a math person, such as yourself, such as myself, that that just means a point. So you have to put the angle symbol in front to show that it's angle X. Angle C corresponds and is congruent with angle Y. Angle D corresponds and is congruent with angle Z. Okay, so that's the first thing we're doing. So we're listing the pair of congruent angles. Then we're going to write out the extended proportions. So if you notice, one extended proportion that they already wrote was side AB, that came from the smaller polygon, over side WX, which came from the larger polygon. Another extended proportion, it would be side BC, which came from the smaller polygon, over side XY, which came from the smaller polygon. So what we're doing is we are always, whenever we're writing our ratios here, to write our extended ratios or extended proportions, notice we're always writing the smaller shape as the numerator. So that means side DC would correspond with side ZY. So DC over ZY would be another extended ratio, which would give us our extended proportion. And the last one would be side DA or AD, it does not matter which way you write it, would correspond with side ZW. Okay, moving on to number 2, we're doing the same thing. Number 2, whoever wrote the problem tried to make it a little bit more complicated by, they did not put the triangles in the same exact order, okay, that you have them in. So what you want to do is you have to kind of picture it. So let's start with angle H. That's probably the easiest one because it's a 90-degree angle. Clearly that's congruent to angle J. Okay, and then let's go up here to angle G. So angle G, which is the smaller of the two angles, would be congruent to angle K. So G is congruent to angle K, and then angle I, which was right there, would be congruent to angle L. Okay, so that would be my listing of my congruent angles. Then I'm going to do the extended proportion. So notice the first ratio is done for you. It has side GH, so that comes from the bigger triangle, over side KJ. So in this proportion, when I write it, I'm always going to take a side from the larger triangle, put it as the numerator. So for instance, side HI. And then underneath it in the denominator, I'm going to mark what corresponds with HI, and that would be side JL. So HI over JL. And then the third one would be GI side, so side GI over side KL. And really, the order that you write the letters doesn't matter. Okay, moving on to numbers 3 through 6. The instructions say determine whether the polygons are similar. So that's the first thing we're going to do. Determine whether the polygons are similar. Then we're going to give the scale factor. That's what SF stands for, scale factor. Then we're going to complete the statement of similarity. Okay, notice in part B it started our statement of similarity here. And if they're not similar, you're just going to write not similar for both A and B. And then you're going to explain why they're not similar. Okay, so how do you tell if shapes are similar? Well, there's two ways you can tell. First of all, if all the angles are congruent, and you could see all the angles here are congruent, that's pretty much going to make the shapes similar, but only for certain shapes. So also to tell if shapes are similar, you want to set up the extended ratios, okay? So what I'm going to do over here is I'm going to write my extended ratios. And ratio is just a fancy way for saying a fraction. And then I'm going to compare them to one another. In other words, I'm going to see if they're equal. And when I write my extended ratios, I'm always going to write the small shape as the numerator, and I'm going to write the big shape as the denominator. Now, you don't have to do that, but you have to be consistent. So if you write the small shape first, for instance 3, every time I write a ratio, the small shaped values have to go on the numerator. So what matches up with 3, but over here, that would be 4. So one ratio would be 3 over 4. Okay, notice I have another 3 over 4. So another ratio would be 3 over 4. Okay, another ratio would be this left side here, 6, corresponds with this left side, 8. So another ratio would be 6 over 8. Then if you notice, I have a second 6 over 8. So these are all my ratios. Now, if they all reduce to the same amount, then that means the shapes are similar to one another. Okay, so if you notice, 3 over 4 can't be reduced. Okay, but 6 over 8 can be reduced, and 6 over 8 reduces to 3 over 4, as does that 6 over 8. So that means, notice, all these extended ratios, they're all the same thing. So that means the shapes are similar. So determine whether the polygons are similar. I just did. The answer is yes. Give the scale factor. So the scale factor is whatever the extended ratios all reduce to. So my scale factor here would be 3 over 4. Or I noticed that some of you decided to divide it out, and some of you, when you were doing this in class, you said 0.75. Okay, that would be okay as well. So either way to represent the scale factor. Then part B, complete the statement of similarity. Okay, so notice we have C, D, E, F. So we're starting at C, we're going to D, then we're going to E, and then we're going to F. So we're going to write this shape in the same order. So we would start at Q, so this would be similar to Q. We would follow the same order. To R, down to S, over to T. So Q, R, S, T. That would be number 3. Okay, moving on to number 4. So are these two shapes similar to one another? All right, that's the first thing we have to do. Determine whether the polygons are similar. In this case, we have two triangles. Okay, well, the way that you tell is you take a look. One way to tell is you take a look at the extended ratios, just like we did in number 3. Okay, so let's take a look at the extended ratios. So when I write the extended ratios, I'm going to write the small shape as the numerator and the big shape as the denominator. So I'm always going to write my ratios as the small shape's values on the numerator, the big shape's value. Let me zoom it in a little bit so it's easier for you to see if you're playing at home. Okay, so let's pick a side from the small shape. Let's pick this bottom side, V to U, which is 3. So what corresponds with 3, but over here, okay, in the big shape? Now, you may want to say, well, it corresponds with 12. Okay, but that's not right, because if you notice, 3 is smaller than 4, so that means the 3 has to correspond with the smaller leg, which would be 8. So 3 over 8, which would make my other extended ratio 4 over 12. Okay, well, now let's see, what do these reduce to? Well, 3 over 8 is already reduced, so you can't reduce that. 4 over 12 reduces down to 1 over 3. So is 3 over 8 the same as 1 over 3? The answer is no. Okay, these are not equal to each other. So since the ratios aren't equal, what does that mean? It means that the shapes are not similar. So right here it says, if not similar, write not similar for both A and B. Okay, so I'm just going to do it this way, not similar. Okay, and then it said explain. So how would we explain that these shapes are not similar? This would be because the ratios are not equal. Ratios are not equal. Okay, the ratios have to be equal in order to make two shapes similar to one another. Okay, moving on to number 5. All right, so the first thing we're going to do is we have this rectangle, we have this other rectangle, but notice the rectangles are not drawn in the same exact orientation. That's the word I was looking for earlier. I couldn't remember it. All right, however, so let's see if they're similar. So how do we do that? We take a look at the extended ratios. Okay, and you write as many as you can. So once again, when I write the extended ratios, I'm going to take the small rectangle, and then that value will go on the numerator. I'm going to take the big rectangle's values and put it on the denominator. So this side here comes from the small rectangle, 3. So what corresponds with 3, but in this rectangle, that would be 4. So one ratio is 3 over 4. Okay, the other ratio would be this side from the small rectangle, which is 8. That corresponds with this side, which is 10. And if you notice, if I turn the shape, okay, if I rotated the shape around, they would correspond. Okay, so the first thing I have to determine is, are these equal? Okay, well, 3 over 4 cannot be reduced, so that says 3 over 4. 8 over 10, we could reduce it down to 4 over 5. So notice, one extended ratio is 3 over 4. The other one is 3 over 5. Well, those are not equal. So since the extended ratios are not equal, that means number 5 is not similar. Okay, so number 5, those two rectangles are not similar. Then we're going to explain, and it's going to be the same explanation as number 4, because the ratios are not equal. Okay, so that's how we tell. Once again, if shapes are similar, their ratios, the extended ratios, they have to be equal to each other. Okay, which means that they'll reduce down to the same amount. Moving on to number 6. Okay, so now if you notice, whoops, there we go, number 6, you can now see it. So now let's, we got two triangles, and notice we have 3 sides of each triangle. So that means when we write the extended ratios in number 6, we'll be able to write 3 of them. So we'll have 3 ratios to determine if the shapes are actually similar. So once again, I'm going to, I'll mix it up this time. I'll write the big triangle's values as the numerator, and then I'll write the small triangle's values as the denominator. So let's pick a side from the big triangle. Let's pick side DB, which is 6. And notice that side is connected by the 49 and the 88-degree angle. So that would be connected by the 49, and then this angle down here has to be 88, because if I added up these 3 angles, they have to add up to 180. So that means connected by the 49. So that means 6 over 4 is one of my ratios. Okay, let's pick another side from the big triangle. Let's pick side BC, which is 9. So I'm going to have 9 over, now notice this is 88. That angle there would have to be 43. So connecting the 88 and the 43 angle here would be this side right here, which is HI, which is 6. There's another ratio. Okay, then my last one would be 12 over 8. So those would be my 3 ratios. Okay, now if I just looked at them and I didn't know anything about fractions, I would go, well, they don't look the same, therefore they're not equal, therefore these shapes are not similar. Okay, but don't jump to that conclusion, because the first thing you need to do is you need to reduce. Okay, so what does 6 over 4 reduce to? Well, that reduces to 3 over 2. 9 over 6 also reduces to 3 over 2. And 12 over 8 also reduces to 3 over 2. So all the extended ratios are equal to each other. So what does that mean? It means the shapes are similar. So then what's the scale factor? The scale factor is whatever the extended ratio is reduced to. So the scale factor would be 3 over 2. Or, once again, I noticed that there were some people dividing that out and some people were saying the scale factor was 1.5. Either answer is fine, because those two values are equivalent to one another. Okay, now let's complete the statement of similarity. So we have triangle BCD. BCD is similar to, And now let's name this triangle. So side BC, those are the first two letters. That's connected by the 88 and the 43, so that would have to match up with side HI. Okay, so it would be HI here. And then D, which is 49, would match up with J, which is 49. Let's make sure we did it right. Is angle H the same as angle B? 88, 88. Is C, which is 43, the same as I, which is also 43? So there we go. There's my similarity statement. Okay, hopefully that makes sense. Number 7. In the diagram below, so here's my diagram below. Let me move it over so you can see it. Triangle NOP, so NOP in that order, is similar to triangle WXY, so WXY. So what does that mean? It means that N, the first letter, is going to be the same as angle W, so that means angle W has to be 49 degrees. The second letter O, which is 58 degrees, is going to be the same as the second letter here, which is X. So that means X has to be 58 degrees. And then the third letters, P and Y, are going to be the same. Okay, so let's find them first. So remember, the three angles in a triangle are always adding up to 180. So to find angle P, I would take 58. I would add it to 49. That is 107. Then I would subtract 107 from 180. That would give me 73 degrees. So that means that angle P has to be 73 degrees, which means angle Y has to be 73 degrees. Okay, so that's going to help us. So the scale factor of triangle NOP, so we're going to do this triangle on the top. Notice triangle NOP, so that's the little triangle. So when we write the scale factor, we're going to put the little triangle or the small triangle as the numerator. 2WXYZ, that is the big triangle. Okay, so let's figure out what the scale factor is. How do you find the scale factor? Well, you have to write all the ratios, the extended ratios. Okay, so let's start with side NO, which is 6. Over what matches up with NO, that'd be WX, which is, I don't know. So I'll just put a question mark right there. I don't know what that is, so that's a question mark. Okay, my other ratio, so then let's go to side OP, which is 4. That would correspond with side XY, which is 10. So there's a ratio. 6 over something, I don't know what that is, 4 over 10. And then my other one would be side NP, which I don't know what that is. So I'm going to call that, I don't know what letter, can't use X, so let's use A. Okay, so that would be A over side WY, which is 12. Okay, so when it says what is the scale factor, there's really only one ratio that I could do. And what does that reduce to? 4 over 10 reduces to 2 over 5. So that's my scale factor, 2 over 5. Okay, part B, what is the measure of angle X? We already did that. That's 58 degrees. Part C, what is the measure of angle Y? 73 degrees. We did that work. Okay, now how about D? How long is side WX? Okay, WX right here, that's where I put that question mark. Okay, so how would I find that? So to find WX, what I'm going to do is I'm going to take this ratio, 6 over the question mark, and then I'm going to set up a proportion, and I'm going to choose one of these two ratios to make it equal to. Now obviously, I would want to choose 4 over 10. Okay, and the reason why you would not want to choose A over 12, because that means I would have 2 unknown values. And then I cross multiply to solve this. So I would do the means, which is 6 times 10, and then I would do the extremes, which is 4 times question mark. So that would be 4 question mark is equal to 60. Remember, the means is equal to the extremes, and then we would solve this by dividing by 4. So the question mark would be equal to 15. 60 divided by 4 is 15. So that means W to X is 15. W to X is the question mark here. Okay? Part E, the last one, how long is N to P? Well, N to P, if you notice, if I go over here, N to P is what I represented by A. So what I would do to solve for N to P is I would set up another proportion. So I would use the A over 12, and I'll do it over here, so move it over so you can see it. Okay, so I would use the A over 12 ratio, And then I would make it equal to one of these two. Now, which one would I choose? Well, I'd choose the 4 over 10 again, because I don't want to have another unknown value, 4 over 10. And I know what some of you are thinking. You're going, Mr. Trutna, you could have put a 15 right there and done 6 over 15. I could have. Okay, and then I cross multiply. A times 10, that's called my means. That's 10A. Cross multiply this way. 12 times 4, that's called my extremes. That's 48. Okay, the means is equal to the extremes, and then we solve the equation by dividing by 10. So that would be 4.8 for A, and A represented side NP, 4.8. Okay, there you go.